In this problem, you have to find it out the what's the work done, or you have to find it out the distance is this traveled on an inclined plane. A mass is moving towards an inclined plane, and there is a coefficient of kinetic friction as well. With this information, you should be able to find it out how far does the block travel along the inclined plane. Again, the concept that I'm going to use for this problem is the conservation of the energy. In this case, the kinetic energy changes into the potential energy, plus some of the kinetic energy is lost in the form of the frictional energy, because there is a friction too. So some energy will be lost in the form of the frictional energy, which is non-conservative energy. But again, the total amount of energy has to be the same. That means the total work done, we have to find it out. Let me draw this one, then it will become much more clear. So in this case, an object mass is moving towards this slope at 5.7 meter per second. What's happening? So, and this is not a frictionless surface, it does have certain friction too. So when this object comes up, it just moves along the distance, and at one point it stops there. So what is the maximum distance it can move to? We have to find it out. First, let's say the object is at certain point, at any point. I'm drawing this one here, at any point here. Okay. The idea is just to draw all the forces onto this diagram. The force is always acting downwards, which is mg. We always resolve this force into two components. The one is perpendicular to the surface, which is mg cosine theta, and along the inclined plane, which is mg sine theta, sine theta. And this angle, if this angle is theta, then this angle is also theta. Okay? And then you have a normal force. This is the normal force. And we do not require this one because we have resolved this into two components. Alright? Now let's say the total distance it has moved along the inclined plane is d. Or let's say from this point to this point. I'm just putting here. And this total distance is d here. If it has moved the total distance d, the amount of work done is equal to the force times the distance. Okay, so we just have to use the total force and the distance. So what are the, as this block is moving along the inclined plane, the friction force is acting backwards. So this is a friction force, and I'm using Fk here, okay, because this is the kinetic friction. So here the total amount of work done is equal to the initial kinetic energy. Okay. First, let's find out what is the friction force. The friction force is equal to mu k times n, the normal force. The mu k and the n is this normal force. This normal force is equal to, you see, mg cosine theta. Mg cosine theta. This is the normal force now. Because all the forces in the perpendicular direction has to be equal, because the system is not moving in the normal direction. Okay. So now the kinetic energy initial or the change in the kinetic energy. I'll just try to like change in kinetic energy. This is from the work energy relationship. The change in kinetic energy is equal to the work done. Work done. You see, at this point, its velocity is 0, so it will be at rest. So there is no kinetic energy at this point. If it has moved the distance d, let's say at this point d, it stops. So when it stops, there is no kinetic energy. So its total kinetic energy is initial kinetic energy, which is equal to half mv squared. And someone can put the negative sign d but it doesn't make a difference. Now let's find out the work done. The work done is total force F net times the distance. You see, the total force and the distance does have the angle between the force and the displacement is the 0 degree. So I'll just use half m. Now let's find out what is the total force. The one force is mg sine theta plus the other force is friction force Fk times the distance. Okay. Now let's solve for d then. What do we need to calculate? Yes, we need to find it out the d. Then d is simply equal to mv squared over 2 mg sine theta plus Fk. You see, Fk is equal to mu k mg cosine theta. Mu k mg cosine theta. Okay, so just plugging all the numbers here. And one thing, this mass, and this mass cancels out. What is the velocity? The velocity is 5.7. So 5.72 square. 2 times g value is 9.8 sine theta. The angle is 11 degree. 11 degree plus 9.8 times cosine 11 degree. Cosine 11 degree. Just use your math. The answer you will get is 3.72 meter. So as you see, in this case, the change in kinetic energy is equal to the net work done. So by using that principle, we calculated the distance moved.